Okay, so hopefully, in your academic career, you learned at one point or another that about the independent dependent variable. And today we are working through learning target U 1.2. Remember, U means it's universal, means that everybody should probably know this one. And this one happens to revolve around the independent dependent variables and how to identify them. So here we go. First of all, there's a couple of things that we should keep in mind in terms of independent dependent variables, and one of those things is making sure that we're all speaking the same language, which in this case means that we are talking about vocabulary. So the independent variable, is the variable that is purposefully changed by the scientist. It's something that is changed to see what happens. Okay, it's easy to manipulate. That is, it sometimes goes by round numbers or whole numbers. Like sometimes people will go like 5 milliliters or 10 milliliters and 15 milliliters. Like usually that's an indication that that's the independent variable. The dependent variable is the variable that you measure. It's the variable that you're looking for the result. Okay, so I changed something with the independent variable, and now I'm watching to see what happens with the dependent variable. Miss Yacarino says that she always remembers the independent versus the dependent variable by saying I, as the scientist, change the independent variable. Because I and I kind of go together. It's kind of how she chooses to remember it. One of the things that's been flying around out there in the internet world amongst parents is this cute little anecdotal story about somebody put on a tweet like, hey, my 6-year-old did an experiment on us. So here's what the 6-year-old did. 6-year-old lost tooth. 6-year-old put the tooth directly under the pillow. 6-year-old waited. And after the third day, finally went to his parents and said, I know the tooth fairy is not real. Parents say, how do you know? Child says, put a tooth under my pillow 3 days ago and nothing happened. So independent variable in this case would be, what do you think? Well, I would think that the independent variable would be the fact that the child lost a tooth but didn't tell his mom and dad, right? Because what happens when you lose a tooth? Well, usually you tell someone, right? So this child's independent variable, the thing that was changed, was not telling someone, and then the dependent variable is waiting to see whether or not the tooth fairy showed up, and apparently the tooth fairy did not. So parent of the year is what I'm saying, not me though. Moving on. I don't know. I thought that was funny. All right. Determining independent versus dependent variable in experimental description. So experimental description really revolves around the idea that if you are reading a lab or you're reading an experiment or you're given an explanation of something that was done, you should be able to identify what the independent and the dependent variable are based on what you've read. So there's a couple of things that we look for. If you see the words measure and record, that's often an indication that we're dealing with the dependent variable. So you know how like in math class in your elementary school and you learn how to do word problems and they were like, get the total of or the sum of, always meant to like add stuff up. You know what I mean? Well, if we ask you to measure or record something, that means that it's usually the dependent variable that we're talking about. The independent variable, okay, usually has some type of logical increments. Like I said before, it might be like 5.0 grams, and then you might have like 10.0 grams, and then you might have like 15.0 grams. Like those are very easy for the experimenter to manipulate and change. And it's usually somewhat logical in terms of how they're changed, okay? And then constant in this class is usually something that's part of the experiment, but kind of always stays the same. So what I mean by that is you might have something like, I performed the experiment at exactly 23 degrees Celsius. Well, why does that matter? Well, that sort of matters because some reactions go faster, excuse me, or slower if there's a temperature change. So if we keep the temperature the same, then that would mean that that temperature is a constant and not affecting the outcome of the experiment. I don't know. Any questions about that? Excellent. Moving right along. Here's an example. In this example, it says a student pulled, in an experiment, the student pulled a set of 3 kilogram blocks with a mass of 1 kilogram, 3 kilogram, 5 kilograms in a straight line across a flat horizontal surface. The student then measured the pulling force, which is the force required to move each block at a constant speed, and then graphed the pulling force in newtons versus the block mass in kilograms. What's the independent variable? So if we're looking for the independent variable, I would say that the block masses. Because it was like 1 kilogram and 3 kilograms and 5 kilograms. And that was something that clearly the experimenter or the scientist had some control over. What was the dependent variable? The dependent variable was the thing that was being measured, which in this case was the pulling force. And again, measured is our key word there. Okay, questions? There is another one, another example of this. Why don't you go ahead and give that one the good old-fashioned try? Give it a shot, and then we'll talk about it. All right, so in this one, I identified the 3 blocks, again, to be the independent variable. The blocks had a mass of 2, 2.5, 3, which is pretty consistent and logical in terms of changing the masses. And then what was being measured was the speed of the blocks because they were being pulled at a constant force. Questions? Excellent. Determine the independent dependent variable in data table. Did I go too fast? All right. So in a data table in GHS and in almost most of the world, very rarely is this not the case. In a data table, the independent variable is always the first column. And the dependent variable is always the second or third or fourth or fifth column. It's just what we've decided is always going to be the case. So independent comes first, dependent comes second. In this case, the independent variable will be the spin rate, and the dependent variable will be the precession rate. Questions about that? Wonderful. Lastly, we have a graph, and we can always determine what the independent variable in the experiment was on a graph because the independent variable is always on the x-axis. So here's my independent variable down here. And the dependent variable is always on the y-axis. And that's that. So any graph you look at will have the independent on the x and the dependent on the y. It's just kind of the way that things are. Questions? All right, then.